Hello, we are team number 2, and today we are going to explain to you how to use the binomial theorem.
But first, let me take a selfie.
No, but first we are going to explain where this binomial theorem comes from. We are going to go with the creator of the Pascal's triangle, Pascal.
Bonjour, je m'appelle Blaise Pascal. Oh non, je vous parle en anglais. I'm Blaise Pascal, and the most important contribution I did in math was the Pascal triangle, which is a triangle of numbers where each number is the two numbers above it added together. How to do it? Well, we need to put 1, and 1. We add up these numbers and we get a 2. We put on both sides a 1. We add up these numbers and we get a 3. We add up these numbers and we get a 3. We put 1 and 1 on the other side. We add up this number and we get a 4. We add up these numbers, we get a 6. We add up these numbers and we get a 4. Then we add a 1, 1. We add up these numbers, we get a 5. These numbers, we get a 10. These numbers, we get a 10. These numbers, we get a 5. 1 and 1. And then you continue.
The relation between the Pascal triangle and the expanded binomial theorem is that in each stage of the pyramid is shown the coefficient of each term.
If we look at the binomial a plus b to the n plus 1 row of Pascal's triangle gives us the coefficient of the expanded form of the binomial. It is the n plus 1 row because the first row of the triangle is any binomial with an exponent 0.
So this is the formula for the binomial theorem. A plus b to the n power equals sigma n k equals 0 n combination k a to the n minus k power times b to the k power, where n represents the degree and k represents which term in the expansion you are calculating.
Use the binomial theorem to expand the expression x minus 2y to the 7th power. To solve this problem, first we organize the variable by the binomial theorem formula. So that is why we have x to the 7, to the 6, to the 5, to the 4, to the 3, to the 2, to the 1, and to the 0. And b, or the other term, is to the 0, to the 1, to the 2, to the 3, to the 4, to the 5, to the 6, and to the 7. And then to calculate the coefficient, we use the number of the Pascal triangle or the combination they give us the number of the Pascal triangle. So we have combination of 7 to the 0. 7 is the degree and 0 is the number we want to get. 7 to the 1, 7 to the 2, and so on. After doing all the calculation, we got x to the 7 minus 14x to the 6y plus 84x to the 5, y to the 2, minus 280x to the 4, y to the 3, plus 560x to the 3, y to the 4, minus 672x to the 2, y to the 5, plus 448x, y to the 6, minus 128 y to the 7. These are the numbers in Pascal triangle made with the combination. Find the last three terms in the expansion of a to the 2/3 plus b to the 20 power.
To solve this we use the same formula, so we have to get the term number 18, the term number 19, and the term number 20. So here's the 20 combination 18, a to the 4/3 power, b to the 18 power plus 20 combination 19, a 2/3 power, b to the 19 power plus 20 combination 20, b to the 20 power, and it gives us that the final result is 198 4/3 to the 4/3 power, b 8 to the 18 power plus 20, 8 to the 2/3 power, b 19 power plus b 20 power. And these are the last three terms of this expression.
Find the 25th term in the expansion of x minus 2 to the 25th power.
For the last problem, we need to find the 24th term in the expansion of this binomial. So it will be 25 combination 24 x times minus 2 to the 24th power, and it gives us 25x times minus 2 to the 24th power, and our final result is 419,430,400x.
In order to solve the problem, we first read the problem, then get the data, investigate the subject in the book, solve the second part of problems, investigate Pascal's triangle, solve the first part of problems, do the flowchart, and get to the conclusion.
We conclude that the Pascal triangle is an easy method to get the binomials with any exponent. We investigate and analyze the method and apply it in our problems. You can use it in real life to calculate the value of big numbers elevated to a power. The application in real life of the Pascal triangle is that the model of cell division, and according to the Pascal triangle and Fibonacci numbers, the planets of the solar system are arranged that way. Also, the Pascal triangle is the universal law of the atomic structure. There is a connection between numbers of electrons and protons on one side and triangular and tetrahedral numbers on the other. So the Pascal triangle is the basic numbers expression in A2.
Thank you!